Hi, welcome to this introductory course on databases. It's impossible to live in the modern world and not know what a database is. You might not know in computer science what all a database implies, what lies within it, and what are all the little details which make a good database management system. However, if someone uses a word database, you immediately think of it as a repository of data from which you can extract information very quickly. Now, why are databases a big deal? This ties back to why is data such a big deal? Data in this world is ubiquitous. Everything about everything is basically stored somewhere. In this modern, super connected world, there is hardly any piece of information about you or about anything else that you encounter that is not stored somewhere. Now, all of these are stored in databases of some sort or the other. Let's talk about the importance of data, basically talk about why is data such a big deal before we see why databases are a big deal and why it's important for you as a student of computer science, as someone who wants to learn programming, wants to learn technology. Why is it important for you to learn about databases? Before we plunge into talking about data, and we'll have a lot to say about that in the lectures to come, let's go back in time and discuss computing performance. So you'll have to rewind 50, maybe 60 years into the past, to the 50s and 60s, and we'll discuss computing performance then and now. Moore's law. If you have heard of Gordon Moore, you'll know that he was one of the founders of Intel. Back in 1965 or so, Moore's law, Moore basically predicted this, which is why it's called Moore's law, stated that the number of chips on a single board or an integrated circuit, as a single board is called, doubles every 2 years. He basically saw the rate at which computing performance was increasing because of this doubling in number of chips. He saw how technology was advancing in soldiering and putting together all these chips in one board. He said that the rate of the increase in the number of chips on a single board doubles every 2 years. And this has proved true for many, many decades after that. So this was Moore's law, and if you are a computer science student, you doubtless have heard of this earlier. Now the question is, why is this important? What difference does Moore's law make? It is extremely important because Moore's law predicated or is the foundation of all the technological advances that we've made in computing. The fact that the computing power in a smartphone today is greater than in the biggest mainframe of 50 years ago is basically Moore's law. As you can pack more and more chips, more and more computing power, more and more components onto a single board into smaller and smaller spaces, we've basically created the smartphone, which has way more computing power than a mainframe did 50 years ago. A mainframe 50, 60 years ago occupied entire rooms, and it could do nothing close to what your smartphone could do today. This is because each component was not powerful, and different powerful components could not be packed together the way it is today. Today we have smartphones. This was unimaginable just 50 or 60 years ago. This explosion of computing power because of Moore's law and obviously all the technological advances which fed into that has made possible stuff one could never imagine earlier. Even science fiction could not imagine the smartphone of today. Don't worry, we are still trying to answer the question of why is data such a big deal. We are getting to it. Now that we have all this computing power at our fingertips, basically, which means we use it all the time. The world entirely, everyone in this world, is moving to a place where we are constantly online and doing something. We always have our smartphones on. Yes, it might be to message, but we are looking up information all the time. We don't have to wait till we are in front of our desktops or wait to ask someone or consult an encyclopedia. Not just are we just looking up information, we are listening to music, we are consuming videos, we are interacting with our friends. We have an entire world online as well as the real world where we participate in person. The fact that we are online all the time means that everything that we do online is recorded and stored somewhere. And basically, companies have figured out that if they use the information generated from the stuff we do online, there is a huge opportunity to serve us as the customer, give us what we need without us asking for it. Basically, that's what the world is moving to. Your smartphone predicts what you're going to do next and gives you the information for it. It does so even today. Maybe not as intrusively as you can imagine. Maybe it does it in little things. It's not as good as it can be. But because we conduct our lives online, smartphones and a variety of data stores across the world can use that information, which we are voluntarily giving it, to predict stuff about us and make themselves useful to us. Now, this can be a good thing and a bad thing, but it's pretty amazing either way. So, let's talk about how this is. So, how do these companies figure out stuff about us? How do they predict this stuff? That's a very interesting question, and entire companies have been built around this notion. So, what do they actually do? Everything that you do online is recorded somewhere. It's true. Companies are constantly analyzing the data that we generate through all our online activities. And by online activities, I don't mean when you actively interact with a website or with a web app or an Android app or an iOS app. All the stuff that you do, you keep a smartphone in your pocket and you move from location to location. Do you have location tracking on? That means you're giving some company some information. Every click, every view, every action is a signal to someone. It's a signal of something. And if you're smart about analyzing these signals, there is potential to build really cool stuff which make a lot of money. That's just a fact, and which is why all companies encourage you to download their app. Make their company's product your habit. The more they know about your habits, the more useful they can be to you. If Facebook is a habit for you, Facebook can make itself more useful for you, thus kind of cementing the relationship between you and Facebook. So let's break this down. I'm sure it's obvious to all of you that all your activity on Facebook, Google search, WhatsApp, everything is tracked and it's open to analysis. Think of how much these companies put together can understand about you. Of course, it requires a lot of computing power, storage, and analysis, and a lot of intelligence to extract information from this, but it's possible. Any website that you use, this is more mundane, tracks how exactly you interact with it. This is how websites make themselves better, make their user experience better. This is kind of scary when stated baldly like this, but this is why there are great user experiences available for you out there. By tracking how you use their products, companies can make their products more useful, more interesting to you. For example, if you use Facebook a lot, how does Facebook know how to pop up the most interesting posts for you? How does Facebook know who your close friends are and whose posts you're interested in? It's tracking what you do on Facebook. How is Google able to serve up such good results for you? If you're logged in, you'll find that Google search is not just great, but it's great for you. Are you used to searching for a lot of coding content? Maybe you're using Stack Overflow a lot. Google kind of tweaks its results so that more appropriate coding content and coding responses, coding answers bubble up to the top, giving you a great user experience. Now that we focused on the George Orwellian 1984 tracking kind of aspects, let's focus on something which is pretty incredible. If you're actually tracking everything about every user, at least the way it interacts with your app, because that's how it works for right now, consider the amount of data generated from all of this. It's a huge, incredible number. And the amount of data generated from people is expected to grow 50 times between the year 2010 and 2020. In just 10 years, the amount of data generated which has to be stored somewhere is going to be 50 times what it was in 2010 by 2020. So let's look at some approximate numbers. In 2010, there roughly was 800 exabytes. That's what EB stands for. Data collected and stored across all computing systems in this world. 800 exabytes. By 2020, this number is expected to reach 40,000 exabytes. 40,000 exabytes. Now, you're probably familiar with what a byte is, but how much is an exabyte? One exabyte is many, many bytes. One exabyte is equal to 10 raised to 18, 10 to the power 18 bytes. That's how much information exists in the world. You have to remember that these are all approximations, but at this scale, you kind of get an understanding of what we're dealing with and what kind of systems need to be built to be able to analyze and store this data. And this number, in one word, summarizes why data is such a big deal. Knowing how to extract useful information from this data for the automation, intelligence, and cool products of tomorrow is a pretty big deal. Basically, knowing how to deal with this data and to get and extract something useful from this is the key to building the future. The products of the future depend on this data. So, how do we store this data? How do we query this data? How do we ensure that the data keeps updated? How do we know that it's not stale data that we're dealing with? How do we know the data is not corrupted? How do we get insights from this data to help users? How do we deal with new information along with the old? There's often old, outdated information and new additional information. How do they interact with each other? And how do we do all this fast? You can't take forever to analyze data because data gets stale pretty quickly. This forms the core foundation of thousands of companies which will be built in the future and which exist today. This is why data driven technologies are cool and useful and in very high demand. So far, we've spoken about big picture vision, but it's not just about cool products or even limited to very big tech companies who work on these reams and reams of data. Data driven business decisions are the key to figuring out trends and the future direction for even old school businesses like restaurants, logistic companies, so on. Having access to this data and being able to analyze this can bring efficiencies in every business. So it's not just about cool products or limited to big companies like Facebook, Google, etc., who work with this data. Every organization needs to be able to understand its own data in order to make decisions derived from it. Data might give you ideas which you've not thought about before. Maybe there is a trend somewhere. Maybe something sells better than another in a certain region of the country. Data will give you ideas which you've not thought of before. And data will tell you if the moves that you've made in the past, the decisions that you've taken in the past as a small business owner, are working out for you or not. So it's not just about large organizations using this data well, whether you're a small business, an old school style business, or a very large business, will help you grow and gain efficiencies and do the right thing for you. An overused and cliched buzzword today is a big data. It may be overused and cliched, but it's very true now that you know how much data is actually stored and how data is expected to grow in the next few years. You know that big data describes it accurately. There are a whole bunch of technologies which help working with these huge data sets. However, at the foundation of all these technologies is the simple database. Now, before we can attack big data and see how to work with these huge data sets across multiple machines, you need to understand the simple database, build a strong foundation of how it works, what is required to make it work. So that's where we'll start. In this course, we'll start by learning about how to work with simple relational databases. We'll talk about what relational means during the course of these lectures. These simple relational databases have been around for a very long time. But in this data driven world, they've become more important than ever. So it's important for a student of big data, if they haven't any prior experience with databases, to start slow, start with the core, which is the simple relational database. These relational databases haven't been outmoded. By no way is that true. Large data sets are stored using relational databases even today. Large e commerce organizations, Facebook, Google, all of these use relational databases for some subsection of their data. Relational databases is where we'll start, and that's what this particular course focuses on. This class is an introduction to databases. It focuses on core database concepts and acts as a stepping stone in dealing with larger and more complicated data sets. That is the real big data analysis, which we mentioned earlier. We are not doing any big data analysis as a part of this course. However, this course is the foundation to all of that. This course is the crucial core skill required to enter the world of data analytics. If that's where your interest lies, then this course is perfect.